Online banking can be a risk. Okay, online banking is increasing in popularity. Online banking can be a risk as it can raise a number of security issues. Obviously, everyone trusts bank for its security. Obviously, we put our money in banks. So SSL can be used as a security method to make online banking safer. So SSL is used. Okay, secure sockets. It's a security protocol. It's okay, we all know this. Now identify and describe three other security methods that could be used to make online shopping, online banking safer. So obviously the first security method in everything is your strong passwords, because these really matter. Okay, strong passwords. Okay, which are, which make it difficult to hack an account. Okay, okay, strong passwords. These would make it difficult for a hacker, for anyone, okay, difficult to hack an account, okay. God forbid you are, entering a password and you tell your password to a stranger, or he or she hears it. So even though he or she is not a hacker, but still he or she could actually use your password to access your account, and then they can take out the money. So that's why strong passwords are hard to remember. So they're also difficult to guess. That's why these would make it difficult to hack an account. Okay, then there's one more thing that's going on nowadays: biometric. So biometric is also a really good option. They could also use a biometric device. Okay, biometric device, because biometric device uses the unique properties of humans, like the eyes, retina scan, or fingerprint, you can say. So biometric device, it actually uses data. It uses data which is unique to every which is unique for every person. Like everyone has a different retina, everyone has a different fingerprint. Okay, so it uses data which is unique for every individual, and it can be, it is like difficult to intercept any your data or your accounts. Okay, so it uses data which is unique for every individual, hence it is difficult to fake. You cannot in any case you can fake it. Okay, now next thing, you can also use a firewall. Okay, firewall could be used, or yes, one more thing could be used. It was also written in a book that you can use of drop down boxes, boxes to select characters from passwords. Okay, to select characters for your password, so that it's difficult for the keyloggers. Okay, so that it prevents spyware. Okay, it's simply keyloggers cannot monitor your key presses, or even if they're monitoring it, so they cannot record your key presses. Okay, so that keyloggers cannot record your key presses. Okay, use the drop down boxes to select characters from passwords so that keyloggers cannot record your key presses. Okay, cannot record the key presses. Okay, and okay, hence it's difficult to fake. And then you can write it over here. You can write that these would make it difficult to hack an account. hence prevent unauthorized access. Okay, then this is done. You can use multiple things. Then there's something called authentication as well. You can also use that two-step verification where you add another level of identification of the user. Okay, so it's also something which can be written to, but these are easier things like strong passwords. You can always write that. You can always write biometric device, use of drop-down boxes, firewalls, proxy servers, or anti-spyware software could be also an option, or encryption, which would make data meaningless. So there are multiple options you can write. It's dependent on your choice. Question 9a. Now, optical storage media can be used to store data. Describe how data is read from a compact disc. It is actually full form of CD, compact disc. So this is a 4-mark question. You need 4 points. Let me think. So what do we have over here? Compact disc is basically a red laser. We know this, that a red laser is used to used to shine. A red laser is used which actually which shines light on the laser beams. You can say which shines laser beams onto the surface of the disc. Okay, which shines laser beams onto the surface of your disc. Okay, and then it also, when it shines the laser beams, okay, then it also on the surface, okay, on the surface, which is your surface of the disc, it has tracks. Okay, it is covered in tracks, and data is represented on the surface using pits and lands. Okay, so when a red laser is used which shines laser beams onto the surface of the disc, so you can write that onto the surface of the disc, data is represented on the surface using what you can call pits and lands. That is represented on the surface using pits and lands. These pits and lands actually determine the binary values. Okay, and okay, data is now red laser is used. Okay, it shines laser beams onto the surface of the disc, and then what data is represented onto the surface using pits and lands. Okay, which determine the binary value, which represent, you can say, binary values. Now the reflection process again comes here, which represent binary values, and then these pits reflect light back. Okay, they reflect light back, so the device can determine then when the light is reflected back, right, so then optical device can determine binary value from the light reflected. Okay, so optical device pits reflect light back. Okay, so binary value is determined from the light reflected. So the reflection process happens over here as well, that a red laser, this is your CD, okay, a red lasers, it shines a laser beam on the surface, and data is represented on the surface using pits and lens. These pits represent binary values. These pits reflect light back, and binary value is determined from the binary values determined by your device, okay, by the optical device. Obviously optical device determines it from the light reflected, okay. The light reflection could tell what the binary value was. So this is quite simple. Again, the reflection process takes place. Okay, then Camel, this is part B. Camel wants to store 16-bit color image file. The image size is 1000 pixels. Calculate the size of the file. Give your answer in bytes. Show your working. Okay, 16-bit color image file. Okay, the image size is 1000 pixel. Calculate the size of this file. So let's think about it. This is a 16-bit and it has 1000 pixels. So it means that 1000 into 16, you'll have 16,000 bits, right? Okay, 16,000 bits. So then, pixels represent the bits. Okay, 1 bit. So if you can see that it's a 16-bit color image file, and the size is 1000 pixels. So 16 multiplied by 1000 would give you, okay, this 16,000 bits, and we know that 1 bit is equal to 1 byte is equal to 8 bits. So it means that 16,000 x byte would be equal to 16,000 bits. So x byte would equal to 16,000 divided by 8. 8 2s are 16, so it's basically 2000. X is equal to 2000 bytes. Okay, 16,000 would give you the file size. Okay, image is 1000 pixels and it is 16-bit, so it's like 1000 into 16 bits, and then 1 byte is equal to 8 bits, so you divide by 8 and get the answer of 2000 bytes. Okay, now describe the differences between primary and secondary storage. Okay, so I have to describe the differences between primary and secondary. This is a 4-mark question, so 4 differences are good enough. So first difference between primary and secondary storage is that primary storage is RAM and ROM. It's simple. Okay, primary storage is RAM and ROM. Okay, while secondary storage is SSD and HDD, solid state drive and hard disk drive. Okay, then the second thing is primary storage, okay, is internal to the computer system. Okay, primary storage, RAM and ROM are inside, you don't see them outside, is internal to the computer, while secondary, it can be external or internal. Hard disk can be inside or outside as well, so it can be external or internal. Good enough. Then what? Primary storage can be non-volatile and volatile, because RAM is volatile. RAM is volatile. Primary RAM and ROM can be, RAM is volatile, and ROM is non-volatile. So primary can be both volatile and non-volatile. Okay, temporary and not non-temporary. Okay, non-volatile, permanent and temporary, which means okay, volatile. Whereas what do you call secondary is only non-volatile. Okay, non-volatile, and it's permanent. Okay, then there's another one, we call it primary. Yes, there's another thing, that primary is directly accessed by the CPU, while if you look at secondary, it is not directly accessed by the CPU. This is something you need to remember, that primary is directly accessed by the CPU, while secondary is not directly accessed by the CPU. Okay, primary is directly accessed by the CPU, while secondary is not directly accessed by the CPU. Okay, so secondary is not directly accessed by the CPU, primary is directly accessed by the CPU. Then 1, 2, 3, 4. Yes, we have 4 differences given. So I guess that's good now. Then this is the last question of this paper. Stick statements about assembly language are shown. Tick whether this statement is true or false. Okay, you have to tick whether it's true or false. Assembly language uses mnemonic codes. Yes, it does. And then assembly language programs do not need a translator to be executed. False. They do need a translator to be executed. Okay. Then assembly language is a low-level programming language. Yes, it is. And assembly language is specific to the computer hardware. Yes, it is. It is specific to the computer hardware. And it is a machine code. No, it's not a machine code. It's not a machine code, because assembly language programs are translated into machine code by a translator. So that's why assembly language programs do not need a translator to be executed, and assembly language is a machine code. That's all. Okay, assembly language is often used to create drivers for hardware. Let me think about it. Drivers for hardware. Yes, it was one of the uses I studied about. Assembly language is often used to create drivers for hardware. Yes, it does. Okay, so this was the last question, and we are finished with this paper. Okay, so this was all. Make sure to like, share, and subscribe this video, this channel, and share this video with your friends. And this is all for now. Bye.